Hi, in this video, I'm going to walk you through solving the 6th free response question from the 2011 Calculus BC exam. So let's take a look at this question. So, question 6, let f of x equals sine of x squared plus cosine of x. The graph of y equals absolute value of fifth derivative of f of x is shown above. Well, that's a lot of information, but let's start breaking it down. Don't get scared yet. Let's look at the first question. Write the first four non-zero terms of the Taylor series for sine of x about x equals 0. Write the first four non-zero terms of the Taylor series for sine of x squared about x equals 0. Well, that's pretty easy, right? Let's get going. Alright, so to write out the first four terms, we need to write out the general term, so we know what to write. So this is something you really should have memorized. It's just, and then we just write out each term, which comes out to x over 1 minus x third over 3 plus x to the 5th over 5 minus x to the 7th over 7. And next, we have to write out the Taylor series for sine of x squared. So if you remember, Maclaurin substitution means that if you have something like sine of x, but you change the inner part to something else, in this case sine of x squared, you can just substitute the inner part into the Taylor series for sine of x, and that will be this Taylor series for sine of x squared. There are limitations to this though. It only works for Maclaurin series, which is where they're about x equals 0. So if you had like x minus 1 to the 2n plus 1 Taylor series, that cannot be substituted. You also can't do Maclaurin substitution if the thing you're substituting in is a binomial or any sort of polynomial. It has to be a monomial. Given that, however, we can just write, and then we just have to write that out. And now we're done. That wasn't too hard, right? On to the next part. Okay, so part B is write the first four non-zero terms of the Taylor series for cosine of x about x equals 0. And then use this series and a series for sine of x squared found in part A to write the first four non-zero terms of the Taylor series for f about x equals 0. What is f? Let's look back at the question. It was f of x equals sine of x squared plus cosine of x. So, but okay, let's not get ahead of ourselves. First, we got to do the first section, which is the Taylor series for cosine of x. This is another one that you really should have memorized. And then we just write out the terms. And there we go. Now we're supposed to use that to find f of x. Well, that's not too bad because we just have to remember that Taylor polynomials can be added together to get the sum of the two functions. So sine of x squared plus cosine of x is just the same as the sum of their Taylor series. We can rewrite that from the previous part as okay, so but they said they only wanted the first four terms. That's a pretty important detail because we have more than four terms here. Remember, terms are ordered by their exponents. So the first term would be this 1. The second term would be this x squared and this x squared. The third term would be this x to the 4th, and the fourth term would be these x to the 6s. The rest of the terms can go take a hike. Now, we just have to combine these together. But then, how do we add this 3 factorial and this 6 factorial? We just have to play around with the fractions a bit, because negative x to the 6 over 3 factorial can be rewritten as negative x to the 6 times 4 times 5 times 6 over 6 factorial, and then minus x to the 6 over 6 factorial. This way we don't have to actually evaluate 6 factorial, because that's a big, scary number. Which just comes out to negative 121 x to the 6 over 6 factorial. And now we're done. All right, so part C is find the value of f's sixth derivative at 0. Sixth derivative? How are we going to get that? They only gave us the fifth derivative in the graph. Well, let's actually take a look at that. In our graph, we can see that at 0, we have sort of a discontinuity looking thing. But we don't know if it's actually a discontinuity or just a very sharp turn in the graph. Well, obviously we can't get any information from the graph, but what about the Taylor series? That Taylor series we just wrote contained the term negative 121 x to the 6th over 6 factorial. And as you know, the Taylor series term is just f to n at, in this case, 0, because it's a Maclaurin series, x to the n over n factorial. And because it's n factorial and x to the 6th, n is obviously 6 for this term. So f sixth derivative at 0 must be the coefficient, which is negative 121. Easy. And finally, let's look at part D. Let p to the fourth of x be the fourth degree Taylor polynomial for f about x equals 0. And using information from the graph of y equals f to the 5 of x, absolute value shown above, show that p to the fourth 1/4 minus f of 1/4 less than 3,000. So basically, they're asking us to prove that the error of our Taylor polynomial at 1/4 is less than 1/3000th. This is a fairly standard case of Lagrange error. It's not that bad, you just have to know how to do it. So how do we do that? Interesting question. So first of all, we remember the Lagrange error equation. And so that's the most our error could possibly be. So the trickier part is figuring out the maximum of that derivative on that interval. So the maximum of the fifth derivative, so in this case, n equals 4, so r fourth less than or equal to f fourth from 0 to 1/4 max, and then times 1/4 to the 5th over n plus 1 factorial. Of course, how we're trying to do it with Lagrange error is we're trying to find the worst case value of x and the worst case value of the derivative to see what's the largest it could possibly be off by. That's why we find the maximum of the derivative. It's like if it were this highest value for the entire time, how far off would we be? So then, maximum value of that derivative, the fifth derivative between 0 and 1/4. So 1/4 on the graph is right about here. So that looks like that's about, it's maybe a little more than 30. So we can call, but it's definitely less than 40. So we can put a little bit of leeway in there. So let's say that the maximum of that derivative is 40. Times 1/4 to the 5th is the same as 2 to the negative 10th over n plus 1, that should be 5 factorial. And as most people should know, 2 to the 10th is close to 10 to the 3rd, which is 1/24. So we can write finally, and then 1/3072 is less than 1/1000th. And check, we proved it. We're done.
Okay, so that problem wasn't too hard. You just have to remember how to do Maclaurin substitution, how to find the Lagrange error, and the standard series for sine and cosine. As long as you know those, it's pretty doable. And if you need more practice, I put some links in the description to additional problems on the internet for you to do. Good luck!